Welcome to the Explainer. We're jumping right into a massive double-edged sword today, the adoption of AI agents in our CI/CD pipelines. Look, on one hand, this tech is absolutely revolutionizing productivity. It's speeding up development cycles in ways we've literally never seen before. But on the other hand, it's introducing brand new, totally unpredictable costs and some truly wild security threats. So today, we're breaking down the source material to really understand the promise, the price, and the protection of AI in DevOps. Here's our roadmap for today. First, we'll cover the AI DevOps revolution. 2, automating the pipeline. 3, controlling AI agent costs. 4, the prompt injection threat. And finally, number 5, securing the supply chain. Section 1, the AI DevOps revolution. Okay, let's dive into this. The integration of AI into DevOps isn't just some passing trend. It's a foundational shift in how we build, test, and ship software at scale. 40%. I want you to just think about that number for a second. According to the Tech 360 guide from our sources, one major sauce company completely overhauled their testing strategy using AI in Jenkins. Instead of just blindly running every single test after a code change, which takes forever, they used an AI model to predict exactly which tests actually mattered based on the recent updates. The result? They slashed their overall build times by 40%. That's a staggering efficiency gain. It closes feedback loops so incredibly fast. And you know, the savings aren't just in raw compute time. They're in extremely valuable human hours. Take Slack's engineering team, for example. They recently tackled this massive headache of migrating hundreds of legacy Jenkins pipelines over to GitHub Actions. By leveraging large language models to automatically translate those complex configurations and replace outdated actions, they saved over 1,300 human hours. That's a real game changer. And this brilliantly illustrates where the entire industry is heading right now. As the Tech 360 source points out, the line between traditional DevOps and machine learning operations is blurring fast. We are rapidly moving away from those reactive, manual pipelines toward predictive, continuous learning systems that can actually forecast resource needs, self-heal, and self-optimize. Section 2, automating the pipeline. So how do we actually put this into practice? Let's take a look at how these tools integrate right into our daily workflows using GitHub Agentic Workflows. This lays out the exact technical methodology for seamlessly invoking tools like the Copilot CLI within a standard GitHub Actions workflow. Honestly, it's incredibly straightforward. First, you define a trigger, like a daily schedule or maybe a pull request. Then you set up the environment, install the Copilot CLI directly onto the runner, and authenticate it using a specific access token. And finally, you run the CLI in programmatic mode, passing it a specific prompt. Boom! Done! When you automate an agent like this, you unlock what's known as continuous AI. You literally just write your intent in plain Markdown, and the agent goes and executes it. You get continuous triage, automated documentation updates, code simplification, proactive test improvements, the whole shebang. But, and this is absolutely crucial, I want you to think of this AI as a highly capable, incredibly fast, but completely naive new junior developer. They can do amazing work around the clock for sure, but they desperately need clear guardrails. Section 3, controlling AI agent costs. This brings us to a pretty harsh operational reality. Unlike your salaried human developers, this junior dev consumes metered compute resources for every single task they do. Managing these autonomous agents means managing metered compute, and GitHub offers 3 distinct budget strategies to handle this. You've got product-level budgets, which cap the entire platform but can be a little blunt. You've got SKU-level budgets for more surgical control over individual tools. And then bundled premium requests, which casts a wide net across all AI tools. But listen up. Our dev activity source warns us about this dangerous overlapping budget problem. If you mix these up, like setting a product limit and an overlapping SKU limit, whichever hits 0 first is going to unintentionally block your team's workflows, which creates the ultimate engineering leader's dilemma: alert only versus hard stop enforcement. Alert only preserves your developer's productivity, which is great, but it provides no actual spending guarantee. It risks a massive surprise bill if an agent goes rogue overnight. Hard stop mode, on the other hand, guarantees a spending ceiling. But if that budget runs out mid-task, it might literally halt a half-finished AI code deployment right in its tracks. To balance this tension, the sources strongly suggest empowering your teams through scope and policy. By utilizing premium request overage policies, which let you turn overages on or off per tool, and tightly mapping your expenses to specific cost centers, you can actually manage these unpredictable costs safely and effectively at an enterprise scale. Section 4, the prompt injection threat. Okay, tone shift here, because frankly, unpredictable costs are absolutely nothing compared to the catastrophic new security vulnerabilities we are facing. Now, what's really interesting about this slide is the harsh reality of how these agents can be exploited in the wild. According to the security researchers at the Cloud Security Alliance, they recently proved that a simple, maliciously crafted pull request comment can instruct these AI agents to exfiltrate your API keys, like your Anthropic, Gemini, or GitHub tokens, right into public actions logs. No way, right? But it's true. This is what we call a prompt injection. It's when untrusted user content conceals instructions designed to manipulate an AI agent's behavior. Think back to that naive junior developer analogy. If a malicious PR comment tells that highly privileged, unquestioning junior dev to post your API keys into the public issue thread, they will actually do it. They just don't know any better. Section 5, securing the supply chain. And the truly terrifying part of all this, because these pipelines are heavily automated, victims don't even need to click a link or approve a pull request for these attacks to succeed. Check out the devastating anatomy of a real-world supply chain attack. It started in November 2024 with a single stolen token from a misconfiguration in the Spot Bugs repository. Fast forward to March 2025, attackers used that exact stolen token to compromise the review dog action. And literally days later, they leveraged that new access to retroactively modify the version tags of a completely different, highly popular third-party action called TJ Actions. 23,000. That single supply chain compromise of a third-party GitHub action ended up affecting approximately 23,000 downstream repositories. To put that into perspective, third-party actions are incredibly high-value targets for attackers because once they get in, the blast radius is just massive. This specific class of attack is known as poisoned pipeline execution, or PPE. It's often linked to the pull_request target trigger. What you really need to take away here is that AI coding tools, which often store high-value authentication tokens locally in your runner environment, have now become an explicit, targeted exfiltration prize in these attacks. Attackers aren't just looking for your source code anymore. They are actively hunting for your AI agent credentials. Fortunately, the major platforms are fighting back. Tools like GitHub Agentic Workflows are actively combating these threats by running their AI agents with read-only access by default. Any operation that requires write access, like pushing code or creating a PR, has to go through strict, predefined safe outputs that require explicit human review and approval. The AI can draft the work, sure, but a human still holds the keys. To wrap things up, let's get you protected right now. Here is your immediate mitigation checklist straight from the security researchers. First, pin all third-party actions to full commit SHAs. Don't rely on floating version tags. Second, eliminate that pull request target trigger for untrusted forks. Third, ditch the static passwords and adopt OIDC-based ephemeral cloud credentials. Fourth, always apply minimum privilege permissions in your workflow files. And above all else, treat all repository content, issue bodies, PR titles, comments, as untrusted input. I want to leave you with a provocative question to really think about. Are your AI agents acting as your best developers or your biggest vulnerabilities? AI and DevOps is an absolute game changer, but balancing this incredible innovation requires rock-solid security and smart, proactive budget oversight. I highly encourage you to audit your pipelines today, put those guardrails in place, and take safe control of your automated future. Thanks so much for joining me for this explainer, and keep building safely.